Welcome to week 7 in the Scuba Educators Equipment Service course. I'm Dan Morelli. Today we're going to be talking about wetsuits and dry suits. And some of you may know this fellow on the left who happens to be Captain Jacques-Yves Cousteau, the man who helped invent the demand regulator, or the modern demand regulator. The fellow on the right happens to work for the Milwaukee Police Department, and they use dry suits in the cause of their underwater investigations and evidence recovery. So let's get started. We know that humans have evolved to exist internally within a very narrow temperature range, and we're known as homeotherms for that reason. We like to keep our temperature pretty close to about 97, 98 Fahrenheit, which is not a problem when we're in air, because unless the air is very cold, we're pretty good at surviving in the air, putting on clothes. In the water, however, the specific heat of water and the heat transfer process is about 25 times the rate of heat transfer in air. So we have to do something to prevent heat from leaving our body at a very fast rate in the water. Even in water that's 90 degrees, a human will eventually become hypothermic in a very short period of time. Surface supplied divers started diving, of course, in the early 1800s, really 1830s, and they developed undergarments and what they called dress or external garments that were waterproof. So the first dry suits were developed by the surface supplied divers in the 1800s. And the first dry suits that were used by these commercial divers were made of woven cotton canvas, basically, with a layer of latex rubber in between. And that was the waterproof layer. The boots were attached, and they had latex seals at the wrist, and then they had a helmet, of course, that was on top of their head, so they didn't really have to seal the neck with a seal. It was actually, the suit was contiguous with the helmet, so you had an airspace that went from the helmet all the way to the feet. The divers wore wool clothes underneath the diving suit to add thermal insulation, and wool is a very good insulator. It also stays warm even if it gets wet, so that was a double advantage for those divers. This design was actually in use for well over 100 years. And you can see in this picture we have on the left a modern replica of one of the historical diving suits, and people still make these, and people get into the heavy gear, what they call heavy gear, and walk around on the bottom and act like they're in Men of Honor. And the guy on the right is probably doing something like that, and that's in what's called a Navy Mark V dress. So same type of suit though, canvas with latex in between. Actually, it's probably got modern rubber, seeing that the cuffs are black, and a spun copper helmet. All right, so let's get into what we're going to be diving. We're not going to be diving Mark V's unless you go to an experience somewhere. In the 1950s, when scuba started to become popular in the United States, there were no wetsuits available because the wetsuit had not yet been invented. So instead, they used an early version of the dry suit, which was a flexible rubber suit worn over long johns or some other kind of garment to protect you against heat loss. And the suits had no zippers because the waterproof zipper had not been invented yet. And so what they had was, in the middle of the abdomen, basically there was a tunnel that you crawled through, and then they rolled the tube up and secured it with clips so it wouldn't leak, kind of like we do with a dry bag these days. Feet were attached. The feet were attached to the suit, and the suit sealed at the face and the wrist. So there was a hood that went over the head, and the seals also kept water out at the wrists. And here we have a picture of some people with, I don't know what those are, cabezone or wolf eels or something, probably cabezone, spear fishermen somewhere out in British Columbia, And these are the original dry suits for scuba, and you can see that the guy on the right has one all wrapped up right here to keep the water from coming in. The downside of these suits is there really was not a way to add air to them, and so as the diver descended, the volume of air in the suit and undergarments would be compressed as a result of the effects of Boyle's law. And two things would happen. They'd lose buoyancy. They would lose thermal efficiency because the suit air volume was decreasing, and they would get squeezed. So if a fold of this suit gets around a part of your skin and starts pushing, it can make a pretty good sized welt, and it hurts. So they learned how to add air by actually blowing air into the side of the hood and then rolling around to get it into the suit, which is a very inefficient way of getting air into a dry suit, and it's not really acceptable in the modern day. But that's what they did back then. And of course they had a lot more fish to shoot, as you can see, which is why we don't have as many of those around anymore. All right, so the wetsuit was invented in 1951, and there's some discussion about who actually invented it. Hugh Bradner, who was an engineer at the University of California, Berkeley, was working with the U.S. Navy to try and help the frogmen or the UDT guys stay warm. And then there's Jack O'Neill from O'Neill's Surf Shop in Santa Cruz, and we know that his suits are still being made today, O'Neill's wetsuits. And then Bob Meistrel, who started Body Glove. So those two guys, they really were at the beginning of the wetsuit, and they're still being made today. Wetsuits are made of neoprene rubber, which is an artificial rubber, which was actually invented by a guy at Notre Dame University, the neoprene was, and working with DuPont. And in the neoprene rubber, they use a chemical to cause nitrogen bubbles to be produced. And the nitrogen bubbles actually are solid bubbles. They're what they call closed cell bubbles. So there's like a little tiny bubble in there that's solid, well, full of nitrogen, but it's not an open bubble, it's a closed bubble. And there's millions of them inside the cloth, and that's what provides the insulation in a wetsuit. To add strength, they will layer a layer of nylon cloth on the outside. In the early days, they only put it on the outside for protection and to stabilize the neoprene. And then on the inside was just slick neoprene. It was tough to get on, so they would use talcum powder to try to get into these suits, which is not such a good idea because talcum powder, no matter how clean it is, always has some asbestos in it. So don't ever take a sniff of talcum powder if you can avoid it. If you're using it as a powder to get into your dry suit or whatever, stand upwind of where the dust is going. So as I said, the wetsuits rely on the nitrogen bubbles to provide insulation. They do not work by letting a small amount of water in and then you warm it up and that's how you stay warm. That's a bunch of baloney, and it always has been. Modern wetsuits have 2 layers of nylon. We used to call it nylon 1, nylon 2 neoprene, and they're really you don't have a choice, and it's better really to have an inner layer too, because the inner layer is more like it's a soft, stretchy layer that makes it easy to get the suit on. And the suits today, the modern suits, are a lot more flexible than the old suits used to be. We also have semi-dry wetsuits, which use seals in the torso area, wrists, and probably around the waist to keep water from surrounding the core trunk area, which is where you have a lot of blood flow. You got some big organs in there that carry a lot of blood, like the kidneys and the liver and major arteries. And so the semi-dry works by slowing down heat transfer from your core. It's kind of the same principle as a Farmer John suit, where you had 2 layers of neoprene over your core. Wetsuits lose buoyancy and thermal efficiency at depth as a result of the effects of Boyle's law, because the tiny nitrogen bubbles are going to decrease in volume as pressure increases. So the thickness of the neoprene will get less at depth, and you will lose thermal efficiency and some buoyancy. Dry suits don't lose either thermal efficiency or buoyancy because dry suits are designed so that the diver can add air back to the inside of the suit. And it's air inside the undergarments that actually provides most of the thermal protection in a dry suit. All dry suits are designed to keep the diver dry, but they can be made of different materials and are. Some dry suits are made of neoprene, which is the same material that's used to make a wetsuit. And the only difference is the manufacturers of the neoprene wetsuits provide seals at the wrist and the neck, and then they have attached boots so that the suit becomes waterproof. You don't have water leaking in at the ankles and the wrist and down the neck like we do in a wetsuit. And then you would have a waterproof zipper as well. The zipper on a wetsuit is not waterproof zipper. So basically the neoprene dry suit is going to start out just like a wetsuit. It's going to be neoprene panels, which are panels of neoprene that have had nylon applied to both sides. They glue the nylon on and vulcanize it. And then you can buy big rolls of this stuff and cut it up in patterns, and what they do is they glue it together and sew it. It doesn't really have to be sewn. You could just glue it. It would be fine, but sewing adds another layer of strength. The neoprene dry suit fits rather snugly. Some dry suits don't fit snugly. They're you buy them a little bit, bigger than you need to, and then you can put more undergarment in. But neoprene you don't really have to do that with because the neoprene itself provides thermal efficiency. You can also add undergarments. Now, at depth, a neoprene dry suit is going to lose a little bit of the thermal efficiency from the suit material, but if you have undergarments and you can put air back into the suit, you'll be just as warm in that suit at depth. If a neoprene dry suit leaks, the neoprene itself does provide some thermal efficiency. So these suits are very popular in places where it's very cold, like Scandinavia. It's dangerous to lose your weight belt with a neoprene dry suit because there's inherent buoyancy in the material itself. So it's one of those deals where it's probably a good idea to wear a harness with a neoprene dry suit. You absolutely do not want to lose your weight. And here's an example of some neoprene dry suits. The one on the left is made by a company in Canada called Abyss, and the one on the right is made by a company out of Sweden called Poseidon. There are other kinds of dry suits. We have what are called envelope suits. So you just have a waterproof envelope around your body, and then you use the undergarment to provide the thermal efficiency. A very common type of envelope suit is a trilaminate suit. And trilaminate suits, it kind of looks like the material you see on a backpack. So it's going to be a woven nylon cloth, and they have 2 layers of woven nylon cloth with a layer of butyl rubber in between, and the rubber is going to be what provides the waterproof capability. The outside layer is typically ballistic nylon, such as Cordura, and it may have things like Kevlar knee pads to protect the suit from the outside. The Cordura nylon is really quite good at providing abrasion and puncture resistance. The advantage of the Trilam suits is they're light, they're flexible, they're easy to get on, and they can work in both warm and cold environments. How they're constructed is trilaminate material is cut and glued and sewn together, and then the boots are glued and sewn to the suit. A layer of waterproof nylon tape is then added over all of the seams, which just provides an extra layer of strength and waterproof. And here's an example of some trilaminate dry suits. These are very popular in Florida with the cave industry, cave divers, and technical divers. The downside to the Tri-Lam suit is that the exterior is rough. Now, we don't really care about that as a recreational diver. It's, the nylon cloth is kind of porous, and so it's very difficult to decontaminate. We kind of talked about that when we were talking about BCs, because BC material is like the same type of material, ballistic nylon. And so some companies have come up with what they call hazmat tri-laminate suits, which have a layer of polyurethane on the outside to make the suit easier to decontaminate. So it gives a slick outer surface. And this is important for people like law enforcement divers that have to dive in places where you may have chemical or biological contamination. Tri-laminate suits offer good puncture and abrasion resistance, but they can be difficult to repair if you get a hole. And guess what? Dry suits sometimes get holes. So here we have the White's Hazmat PS dry suit. You can see that it's got the slick polyurethane surface, which is easy to soap up and decontaminate. And on the right, the Viking Haztech suit, same thing, polyurethane shell type suit. The last type I'm going to talk about is vulcanized rubber. Vulcanized rubber dry suits are constructed of woven cloth, which is coated in EPDM rubber, ethylene propylene diene monomer. You don't have to remember that. It's an artificial rubber. It's resistant to a lot of chemicals, but not all. But it's better, it's longer lasting in terms of ruggedness and life of service than natural rubber, which is why they use it. So rolls of this EPDM coated rubber cloth are delivered to the dry suit company, whoever makes it, and using a pattern, they'll cut out panels from the cloth, they'll sew them together, including the boots, and then they'll put EPDM tape on all the seams. The entire suit is then put into what's called vulcanization process. They take the suit and they inflate it, and they use heat and pressure to create all the rubber to form a single unit, basically. So the tape, the material, it all becomes a single unit. So the suit is waterproof completely exteriorly. Then they add seals to the suit, and which we'll talk about a little bit later. But vulcanized rubber suits come in several thicknesses. The sport suits are about 50% less thick than the commercial heavy-duty suits, but they're still pretty thick and rugged. The downside of vulcanized rubber suits is they're kind of heavy, they're bulky, they're maybe a little bit more difficult to swim in, a little bit less flexible, and they're more expensive than the laminate suits. But rubber suits are really preferred by law enforcement divers and commercial divers and scientific divers. Some people like them, some don't. This is a Viking vulcanized rubber suit. They're very easy to patch because the outside is rubber. So even if you don't have the official kit that comes with the suit that's got patches and glue in it, you can get a tire patch kit at just about any auto parts store or bicycle shop and patch the suit. Very, very easy. All dry suits have a waterproof zipper. Typically the zipper is on the back of the suit, but it can be across the front in a diagonal, and the Poseidon actually has a zipper that goes around the neck. They call that a self-donning suit. I'm not sure how easy it would be to don it. Anyway, I think you have to be a little bit of a contortionist to get that zipper around your neck. But they all have a waterproof zipper. They all have an exhaust valve, which is typically close to the left shoulder, and they have an inflator valve, which uses interstage pressure air, just like your BC, and the inflator valve is typically found in the center of the chest. So if we look back at if you remember the slide before, you can see the valves on the suit. Wetsuits. Wetsuits are constructed from panels of nylon-covered neoprene. The wetsuit material is cut out in a pattern. The seams are glued and sewn. And a few might use neoprene tape. That was pretty common in the old days, but you don't really see that many suits with tape on them anymore. The sewn and glued seam is a pretty strong seam. Wetsuits come in thicknesses of basically 3 to 7 or 8 millimeters, depending. And once you get past, that thickness, you really ought to think about using a dry suit. However, I did find that there are a couple of suits that are as thick as 9 millimeters, and there's a Russian suit that is 11 millimeters thick, and they claim that it's good for really cold water. But honestly, in really cold water, I want to be in a dry suit. The downside to those really thick suits is you got to wear a lot of weight, and if you lose your weight belt, you're going to become flying to the surface like a Polaris missile. So here's a couple of pictures of some one-piece wetsuits. The Henderson on the left there, body glove in the middle, and on the right is that 11 millimeter Farmer John Sargon suit from Russia. The one-piece suits are not as warm as what we call Farmer John or Farmer Jane. Farmer John or Jane suits would use a bib type bottom, so no arms, so it looks like you're wearing bib overalls, but long legs, and then a top that's got short legs and long arms. You can double the amount of rubber that's over your core using a Farmer John or Farmer Jane. So they're much warmer suits and a little bit more versatile than the one-piece suits, because you can, in warmer water, you can just use the top part. Some manufacturers, of course, everybody's trying to get in on the green revolution. And we don't know how green these things are, but they claim that over 80% of the nylon is recycled from drink bottles. Well, that's not really a good idea, because drink bottles are made from oil that comes out of the ground, but I guess it's better than throwing it into the landfill. And the neoprene itself is made from plant-based materials, not from probably the regular neoprene is probably made from oil when it comes right down to it. So it's probably a greener product to buy green preen. Scuba Pro has one as well that they say is, a lot of their materials are recycled. So care and maintenance. On a wetsuit, you want to rinse it after every dive. Things that are bad for nylon: chlorine, UV light, and urine is bad for the neoprene. So do not pee in your wetsuit. Wash with mild soap solution on occasion. Make sure the zippers are well rinsed. Salt can build up and freeze the zipper. I think that would take a long time to happen, but I have seen it happen on dry bags, so just make sure you rinse your zipper as well. You want to get salt and sand out of there if you've got any on there. Dry the wetsuits on wide hangers and in the shade and away from ozone sources. Electric motors make ozone. Ozone is bad for the nylon. UV is bad for the nylon. The thing about wide hangers is you want to make sure that you don't crease the wetsuit material, because if you crease the material, it can cause the nitrogen cells to break down, and so you end up with losing a little bit of thermal efficiency right there at that seam, and it's going to shorten the life of the neoprene. All right, check for punctures, tears, seam separation, or unraveling thread. And a neoprene wetsuit is actually easy to repair. There are a bunch of different companies that sell seam cement or seal cement, and it's basically, O'Neill's got their neoprene cement, McNett. You don't have to buy a name brand. There's other brands out there, but they do the same thing. Small holes, you can just put a dab of seal cement on it, and you can also use it to tack down the loose end of a thread that happens to be coming undone. If you have a cut or a seam that's coming apart, what you want to do is make sure your suit is clean and dry. Just as a caution, don't use too much cement, because if you get it on there, it's going to be tough to get it off. So be careful how you're putting cement onto the fabric or the material of the wetsuit. Do not breathe the fumes of this stuff. It's nasty. It's organic solvents that are not good for your liver. And also, the outside of the jar says extremely flammable, so don't be working around open flames or sparks if you're using neoprene cement. For holes, use a small amount, fill the hole, let it dry. For tears or seams separating, put a bead of cement on each side and let it dry. And when it's dry, put a second bead on each side. And when that material, the second one, is tacky, press the two sides together and hold in place for about 5 minutes. I would wait 12 hours after doing that to make sure that the solvent has completely left the material and it's set up before you want to use your suit. Dry suits. Dry suits should be rinsed after every dive. Rinse the surface of the suit, rinse the seals, rinse the zipper. You want to really rinse that zipper on the outside to make sure there's no sediment or anything in it. And then you want to rinse your valves. The one on the right is the exhaust valve. Just run water into that. And on the left is a inlet valve or inflator valve. You want to make sure you rinse the whole thing, including the fitting, quick disconnect fitting. If the inside of the suit is sweaty, rinse it out. Just run some fresh water through it. Wash the latex seals with a mild soap solution. And dry the inside of the dry suit. So turn it inside out and hang it out of the sun and make sure that the inside's dry, and then put it right side out and dry the outside. If you don't dry the inside, you're going to get mildew on the inside of that dry suit, and that's not good. Latex seals need to be powdered with. In the past, we used a lot of pure talcum powder. I still use it, but I'm very careful about what I do with pure talcum, because you've probably seen in the news that Johnson & Johnson got sued and lost a lot of money because of asbestos toxins. Well, the asbestos that's in talc can cause cancer and cause all kinds of problems. So you want to make sure that you don't breathe talcum powder. So some people use cornstarch to powder the seals, but before stowing the suit, you want to powder the seals for sure. It keeps the seals it makes them last longer. Dry suits should be stored rolled up with the zipper stretched across the suit in a real gentle curve. You don't ever want to fold a dry suit zipper tightly, because if you do, you can break the teeth. And if you damage the teeth, you have to have the whole zipper replaced, and it's very expensive. Clean your zipper once in a while with a toothbrush and soapy water, and then occasionally you want to wax the outer teeth with paraffin. So just get a piece of paraffin wax, close the zipper, rub some wax into the teeth, and that provides lubrication. Careful with that zipper, they're very expensive. Repairs are easy for rubber dry suits. The dry suits will typically come with a spares kit, which has powder, wax, glue, and patch material in case you get a hole in your dry suit. So if you do have a puncture, you want to find a patch that's appropriate to the size of the puncture, and they'll give you 6 or 7 different patches inside that kit. And mark off the area. You can use a little bit of chalk or a pencil. And what you want to do is make sure it's clean. So take some lighter fluid, clean it up, get any solvents or oils off the material, the rubber. And when the lighter fluid is dry, use a piece of sandpaper to scuff up the material, the rubber. And there is actually a piece of sandpaper in the repair kit. And then what you want to do is take a thin layer of glue on the area where the patch is going to go and coat the suit material, and wait 3 to 5 minutes. And at the same time, you want to put a thin layer of glue on the underside of the patch. Now, when the patches come in the kit, they're sealed On the bottom side is a piece of foil. The top side is a plastic sheet. So it's just keeping that patch fresh in between those two layers. So you're going to wait 3 to 5 minutes. And at that point, the glue is going to be still probably a little bit tacky. Then you take the underside foil off the patch, put the patch down over the cement that's on the suit material, and you roll the patch with a wallpaper seam roller or something very similar to that, while leaving the plastic on the top of the patch. So here's a good example of a wallpaper roller. You can buy these anywhere. Wait about 5 minutes, remove the plastic, and dust the top of the patch with talc or cornstarch. The suit can be dove almost immediately. Laminated dry suits, tri-laminates. Patch the inside surface with a patch and a 2-part adhesive made by a company called Bostik. I'm pretty sure it's a urethane adhesive. Clean the area with alcohol, the area that's going to be patched, and let it dry. Using a brush, work the adhesive down into the nylon cloth. You want to make sure that it saturates that cloth. You want to get to the butyl rubber layer that's on the other side of that cloth. Let that layer dry completely. And do the same thing with the patch. So put glue on the bottom side of the patch and let it dry. And then put a second coat of glue on the suit and on the patch and let dry until tacky. Place the patch on the suit and roll it flat. And I would give that one some hours to dry. Dry suit valves need to be serviced occasionally, similar to servicing BCD valves, so exhaust and inflator valve. The exhaust valve simply unscrews, and inside you're going to see something very similar to a BC overpressurization or dump valve. There'll be a soft seat, a hard seat, and a spring. And if the soft seat, the rubber material, is heavily scored, you can flip it over, or you can get a new one. Get a repair kit from the manufacturer, and then once you've put the new seal in or flipped it over, reassemble. The inflator valve works very similar to a BCD inflator valve. So you're going to have a button, you're going to be pushing, and inside the valve are O-rings that are used to seal the air from getting into the suit until you need to push the valve and get some air in there. So when the cylinder is on and the regulator is pressurized, you got interstage pressure coming down to that inflator valve, and inside the valve the O-rings are holding back that pressure. When the O-rings start leaking, the inflator valve is going to leak in the on position, just like the valve on a BCD. So when your dry suit starts filling up and you don't want it to, that's the time to fix it. No, actually, you should do maintenance probably before that. But if that happens, it's very easy to deal with that underwater. You simply disconnect the inflator hose to stop having your dry suit inflate, because having a dry suit inflate is dangerous. It can float you to the surface at a rapid rate. So disconnect the hose. At that point, you want to have your valve serviced. So the valve needs to be taken apart. You take the valve apart, you clean it, you have the O-rings replaced and lubricated with silicone grease, and put it back together, and it'll be good for another few years. We know that dry suits rely on seals to stay dry, typically neck seal and wrist seal. We know there are different materials that dry suits use. The most common one is latex, but these days there are other materials being used, including silicone. There's a material called Polytex that's a little bit longer lasting than latex. And you can get neoprene seals. Now some of the commercial suits come with neoprene seals. They're a little bit more rugged. They last longer. They're not as dry, I tell you that, as latex seals. Latex, though, is an uncured rubber. And even if you don't use your suit, if you leave it in the bag and don't even take it out of the suit, the latex is sitting there breaking itself down. The solvents inside that rubber are actually causing the rubber to degrade. And so after about 5 years, those latex seals will have to be replaced. Now, on many suits, the seals are actually glued to the suit material, but there are other ways to do that. Silicone and Polytex seals are not glued. They're mounted in a permanent ring system. So the suit is actually got a permanent ring on the sleeve or the neck, and the seal is mounted to a ring that mates to that other ring on the suit. Because silicone and Polytex are very difficult to glue. In fact, silicone's impossible to glue. So if you have silicone seals, you got to use a ring system. If your seals are glued and one rips or tears when you're out in the field at the dive site, and there's nothing you can do about it. You have to send it to somebody to repair, a dry suit repair facility. And there are some available. There's one in Gainesville, or actually in Newberry, called 3D Diving. And High Tech Diving in Punta Gorda, Florida is another one. But there are others. If your seals use the ring mounted system and you happen to have spares in your Dive Master kit, in your dry suit bag, you can change out the seal right there in the field and go right back to diving. And here's an example of a couple of ring-mounted systems. The one on the left is made by a company called Cytec. That's the same company that makes exhaust and inflator valves for dry suits. In this case, it's a blue silicone seal that's mounted to a ring that's permanently mounted on the end of the dry suit arm. And this one actually incorporates a glove system too. Now, dry gloves are a really good thing to have in very cold water, because a dry glove with insulation will keep your hand much warmer than a wetsuit glove. And on the right is DUI, company in California. They have a system called Zip Seal. So if you had zip seals and one of your seals tore or was punctured, and you carried an extra one with you in your bag, you can replace it right then within a number of minutes. Questions? Send me an email or a text, and I'll talk to you soon.